Greetings. We now want to derive this simplified version of the Henderson-Hasselbalch equation that's in the book, in contrast to the actual Henderson-Hasselbalch equation here. And the strategy of this is really simple. When you started off with a certain amount of acid HA, okay, and the molarity of the acid times the volume of the acid initial was the moles of HA initial. You started at, and this is down here in the flask. As you start adding base, the HA reacts with the NaOH, and it becomes, the hydroxide from the NaOH grabs the proton, and it becomes A minus plus H2O. So what is happening is that you're converting HA to A minus as you add strong base, okay? And when you reach VE, you've neutralized all. So the moles acid initial is equal to the moles base at the equivalence point. And this is equal to the molarity of the base times the volume of the base at the equivalence point. So we can now come down here and we can say that pH equals pKa. And I'm now going to derive this here. So I have plus the log of A minus, which is the moles of A minus over the volume total, divided by the moles of HA over the volume total. Volume totals cancel. Now the moles of A, so I can now say this is equal to pKa plus the moles of A minus, okay, is the moles of the base that we added. In other words, at any point. So if I'm at this point here, I've neutralized this much. I take this volume and multiply by the molarity of the base, and that's how much I've neutralized. So this would be equal to plus the log of the molarity of the base times the volume of the base at any point, okay? And we're just going to say this point here in this drawing, okay? And then we divide by the amount of acid that is left over. In other words, we haven't added enough base to neutralize all the acid, so the acid is the equilibrium, the excess reagent. Well, the amount of acid we started with is minus the amount neutralized is the amount left over. But the amount we started with is equal to the amount of base at the equivalence point, okay? So I could put either of these into here, but I'm going to put the molarity of the base times the volume of the base at the equivalence point. So that's the total moles of base required to neutralize the total moles of acid that we started with. They're the same number. And then, but I've already neutralized this quantity here, MbVb, okay? Now the MB's cancel, and I have this derived equation. Now, it's very simple to visualize this. Let's just say this is 50 mils, okay? When I'm gone down to 10 mils, I've neutralized 10 50ths, and I have 40 50ths to go. When I get to 20, I've neutralized 20 50ths, I've got 30 50ths to go. When I get to 30, I've neutralized 30, I have 20 to go. When I get to 40, I've neutralized 40 50ths, I have 10 50ths to go. Because these are in a ratio, okay, the ratio of the volumes of the base at any point to the total volume required to neutralize it is the same as the ratio of the acid remaining divided into the amount of acid that you had neutralized. And when I said over the total volume, what I meant to say was the amount remaining, okay? So this is the total volume, and at any point in time, the amount neutralized, let me get another color in here, the amount neutralized plus the amount remaining must equal what you started with. Okay, hopefully this makes sense.